There's a place on Earth that's impossible to see except as water. From a plane, a satellite, or a ship, it looks nothing special. No contours, no shoreline, no shadows from mountains. Only the ocean. Deep, calm or rough, but always equally endless. This place is called Point Nemo. It wasn't discovered by sailors. It wasn't sought after by explorers, nor marked on maps as a new island. It's always existed, but for a long time, no one asked the question. Where on the planet is the point furthest from any land? It wasn't until the late 20th century, when digital maps became accurate to the meter, that it became possible to calculate this location mathematically. Engineer Aravoya Lucatela launched an algorithm that ran through millions of coordinates, comparing the distances to every coastline, every island, every landmass. The Earth is a sphere, and distances on it are measured by arcs. Step by step, the computer searched for the point where the arc to the nearest land would be longer than anywhere else. In the end, the calculations converged in the South Pacific Ocean. The nearest landmasses turned out to be tiny and remote. Ducie Island in the Pitcairn Islands, Motu Nui off Easter Island, and Mahé Island near Antarctica. Each is approximately 2,500 kilometers away. It's hard to grasp this distance. We're used to thinking in terms of cities and countries. 2,500 kilometers is a flight across half of Europe. It's the distance from Moscow to Berlin and back. And in all directions, there's only water. If you stand at this point on the deck of a ship, the people closest to you might find themselves not on land, but in orbit. The International Space Station passes at an altitude of about 400 kilometers. At certain moments, it truly is closer to you than any continent. The point was named after Captain Nemo, a Jules Verne character. The name turned out to be apt. Nemo means nobody, and within a radius of thousands of kilometers, there really is almost no one. The South Pacific Ocean itself rarely receives attention. The main trade routes lie further north. There's no heavy shipping traffic, no tourist lines, no major ports. These waters lie within the so-called Roaring Forties and Furious 50s latitudes, belts of persistent westerly winds that skirt the planet unhindered. The wind here can blow for weeks without encountering land. It propels waves thousands of kilometers. Even in clear weather, the surface is rarely completely still. Long ocean swells slowly lift and lower the vessel, creating a sense of the breadth of vast space. Point Nemo is located within the South Pacific Gyre, a giant system of currents that slowly rotates clockwise. At the center of this gyre, the water is relatively stable. It does not actively mix with coastal zones. There are fewer nutrients here than on the continents, resulting in lower biological productivity. This region is sometimes called an ocean desert. This doesn't mean a lack of life. It means sparseness. There's less plankton, fewer fish, fewer birds. The space feels emptier than other parts of the ocean. During the day, the water here often appears darker. Due to the low concentration of suspended particles, it is clearer. The sunlight penetrates deeper before dissolving into the blue. The horizon remains perfectly flat. There are no silhouettes, no signs of approaching anything. As the ship passes the coordinates of Point Nemo, nothing outwardly changes. There's no buoy, no marker, no noticeable current. The navigation instrument shows a match, and that's it. The waves continue to roll. The wind continues to blow. But a realization arises inside. There is no land within a radius of 2,500 kilometers. If a distress signal is sent, help will take a long time to arrive. Even with satellite communications, a rescue vessel must travel a vast distance. And this distance is real. It can't be shortened by a glance. At night, the space changes. If the sky is clear, the stars become unusually bright. The southern hemisphere reveals constellations rarely seen by those in northern countries. The Milky Way stretches across the sky, reflected in the water. Sometimes the Magellanic Clouds, small satellite galaxies of the Milky Way, are visible. When clouds cover the sky, the night becomes dense. The horizon disappears completely. Water and air merge. Even the speed of a ship is difficult to perceive without reference points. At this point, there are more than 4 kilometers of water beneath the keel. The pressure at this depth exceeds 400 atmospheres. Light does not penetrate. The temperature is close to zero. This is another world, existing parallel to the surface. If we draw a vertical line through Point Nemo, it connects 2 limits, the cold depths and the orbit above the planet. And in the middle, there is a thin layer of water, air, and human presence. Point Nemo exhibits no anomalies. It doesn't generate any more storms than other areas of the Southern Ocean. Its uniqueness lies in its scale and absence. In a world where it seems that everything has been measured and mastered, there remains a space where man is a rare guest. And that's what makes it special. Looking at a globe, Point Nemo appears to be just a tiny dot in the vast blue. But when you start to delve into the numbers, you realize this isn't just a geographic curiosity, but a rare example of absolute remoteness. The South Pacific Ocean is one of the most undeveloped regions on the planet. There are no dense shipping lanes here, no crossings of transatlantic or trans-Pacific shipping lines. Even fishing vessels prefer to stay closer to the continents, where the waters are richer in life. At the center of the southern gyre, the ocean seems separated from the rest of the world by invisible boundaries. This isn't a physical wall, but a combination of winds and currents that keep the water in a slow rotation. This gigantic body of water lives at its own pace, barely mixing with coastal areas. That's why the area around Point Nemo is sometimes called an ocean desert. But an ocean desert isn't about sand or heat. It's about sparseness. There's less plankton, fewer fish schools, and fewer seabirds. The area seems less populated than other parts of the ocean. During the day, the horizon remains unchanged. There are no clouds clinging to the mountains, no shoreline to hint at the approach of land. Even the color of the water here is different, deeper, more saturated. Fewer suspended particles allow the light to penetrate deeper before dissolving into darkness. If the ship is moving slowly, you can see long ocean swells passing beneath the hull. These waves could have originated thousands of kilometers away, off the coast of New Zealand or Antarctica. They traveled a long distance without encountering land and retained their shape. Southern latitudes are known for their winds. The roaring 40s isn't a poetic image, but a stable belt of westerly winds that circles the planet unimpeded. In the absence of continents, the wind can build for weeks, creating a steady flow of water. And yet, Point Nemo isn't a storm epicenter. It's not known as a particularly dangerous zone. The storms here are the same as in other parts of the Southern Ocean, but the lack of land around them makes them seem larger. Nothing limits the view. Nothing creates contrast. If you stand on the deck on a clear day, you can see the horizon, a perfect circle. It's a rare sensation. To see the world without obstacles, without landmarks, without signs of approaching anything. After a few hours or days, this begins to affect perception. A person becomes accustomed to the fact that the horizon is always empty, that no silhouette will appear unexpectedly, that the space around is truly continuous. Navigation instruments confirm movement, but the visual world remains the same. This creates a sense of stillness, even when the ship is traveling at good speed. At night, this continuity becomes even more noticeable. When the sun sets below the horizon and the sky darkens, space loses depth. If the sky is clear, the stars become the only landmarks. They are reflected in the water, and the boundary between sky and ocean is blurred. When the clouds are thick, the world becomes a closed sphere of darkness. Water and air merge. Even the waves are difficult to discern. The ship seems to move within a black space without beginning or end. At such moments, the depth beneath the keel is especially acute. More than 4 kilometers of water separate the surface from the bottom. The pressure there is capable of crushing any unprotected structure. Light does not reach there. The temperature is close to freezing. This vertical scale is one of Point Nemo's key features. Not only is it horizontally distant, but it also combines 2 extreme dimensions: ocean depth and orbital altitude. Sometimes on a clear night, you can see a satellite slowly passing across the sky. It's a tiny, glowing dot, moving steadily and silently. At such moments, you get a strange feeling. The people closest to you might be up there, above you, not on land. This isn't a romantic metaphor, but a geometric reality. The orbit is closer than the continents. Point Nemo reminds us that Earth is primarily a water planet. We tend to think of land as the center of the world, but the continents occupy a smaller portion of the surface. Most of the planet is ocean, and at its center lies a space where humans are almost absent. Not because you can't get there, because there is rarely a need to go there. And this is precisely its main feature. If we consider Point Nemo not as a coordinate but as an area, it becomes clear that it's not a single meter of ocean surface, but an entire zone of remoteness. The center is calculated mathematically, but the isolation zone itself occupies a vast area. It encompasses thousands of square kilometers of water, all equally distant from land. The South Pacific Ocean rarely makes the news. It's not the site of major military conflicts, has no major trade routes, and is not home to rich fishing grounds. These waters lie off the beaten path. Even airplanes rarely cross them. Most air corridors run further north. That's why the absence of any traces of civilization is so noticeable here. There are no floating buoys, no fishing nets, no stray containers torn from ships. Even the occasional traces of plastic are less common than in the northern parts of the ocean. But this remoteness doesn't mean absolute purity. The ocean is bound by currents. Particles released into the water off the coasts of continents can travel for years. The southern gyre slowly collects and stores them within its system. At the center of the gyre, the concentration of pollutants is lower than in the northern garbage patches, but completely isolated areas no longer exist. However, visually, Point Nemo remains one of the most empty areas on the planet. The climate here is determined by the southern latitudes. Winds are steady, pressure changes slowly, and cyclones form over cold waters and move from west to east. Storms can be strong, but they are not confined to this point. They are part of the overall Southern Ocean system. Sometimes after a storm, a rare calm sets in. The surface smooths out, and the long waves gradually fade. During these hours, the ocean appears almost motionless. Looking at it from a distance, you might think it's a frozen surface. But even in calm weather, water moves. Currents continue their slow rotation within the gyre. Beneath the surface, a complex structure of temperature layers remains. The ocean is never completely still. Over time, a person in this area begins to notice the slightest changes: the hue of the water before sunset, the shape of the clouds, the direction of the wind. In a space devoid of external landmarks, attention shifts to details. The days here are all alike. Dawn arrives without changing the landscape. The sun rises above a perfectly level horizon. No shadows from the shore, no mountain silhouettes, just light and water. The sunset is just as calm. The sun slowly sets, painting the surface gold and red. Then comes the night, deep and clear. Spend a few days in this region and you begin to appreciate the scale of the planet. We're used to perceiving the Earth through its continents, but here, in the middle of the ocean, land becomes a distant abstraction. Within a radius of 2,500 kilometers, there is not a single city, not a single port, not a single light visible in the darkness. This is not a threat. It is a fact. Point Nemo is a geographical reminder of the size of the Earth. In a world where satellites map every square kilometer of the surface, where routes are calculated down to the second, there remains a place where physical distance remains palpable. And as the vessel leaves this area and begins to approach more active waters, changes become noticeable gradually. First, voices appear on the radio. Then, the tiny light of another vessel can be seen on the horizon. The world once again becomes filled with signs of human presence. Only then does it become clear how rare the state of complete emptiness was. Point Nemo demands no attention. It offers no spectacle. It conceals no legends. Its strength lies in its absence. This is the place where the land truly ends, and where the ocean becomes the only dimension of space. When the coordinates of Point Nemo became known, it didn't lead to an influx of travelers. Unlike the poles or the highest peaks, you can't come here for a symbolic step. There's no solid surface to set foot on, no flag to plant, only water. Nevertheless, since this location was discovered, dozens of ships have passed through it, not specifically for the record, but along the way, during circumnavigations, scientific expeditions, and oceanographic projects. The first yacht crews who deliberately plotted a course precisely through the coordinates described this moment simply. The navigation system showed a match. The captain made a note in his log. No change in the environment occurred. The ocean remained the same. But the realization came later. When the ship had been in the area for several days and hadn't encountered another ship or a single radio signal, a sense of true isolation began to set in. It wasn't anxiety or fear, it was an awareness of distance. The South Pacific is one of the least populated maritime regions. Even modern trade routes bypass it. Fishing vessels prefer areas with higher biological productivity. There are no tourist lines here at all. Some solo circumnavigators passing through southern latitudes have noted that in this region, days can pass one after another without a single encounter with another vessel. Radar remains blank. Radios are silent. Even airplanes rarely leave contrails in the sky. One French navigator wrote in his journal that on his fourth day in the center of the Southern Ocean, he first felt the absence of a horizon as a direction. Visually, everything looked the same ocean in every direction. Navigation confirmed their movement, but the surrounding world remained unchanged. Scientific expeditions approached this region differently. They were interested in the processes occurring in the center of the South Pacific Gyre. At the beginning of the 21st century, ships were sent here to study the distribution of microplastics. It was hypothesized that the central parts of the gyres could accumulate particles carried by currents. The results were revealing. Microplastic concentrations here were lower than in northern subtropical zones, but they were still present. Even the most remote ocean location was not completely isolated from human activity. Other studies focused on water composition. Temperature, salinity, and dissolved oxygen concentrations were measured. At the center of the gyre, the water is relatively stable. The layers mix slowly. Nutrients are scarce. Biological activity is lower than in coastal areas. This confirmed the idea of an ocean desert, a space where life is sparsely distributed. But the expeditions also recorded something else, a special acoustic environment. Sound propagates underwater differently than in air. Low frequencies can travel thousands of kilometers across ocean basins. Hydrophones were deployed in the South Pacific Ocean to record natural signals, the cracking of Antarctic ice, underwater earthquakes, and the rare calls of marine mammals. In the late 1990s, one such signal, codenamed Bloop, was detected in these very latitudes. Its source initially raised questions, but was later linked to ice processes. Nevertheless, the very fact that the ocean was generating powerful acoustic events in this remote region heightened interest in these waters. At night, expeditions often observed bioluminescence. As the vessel cuts through the water, microorganisms emit brief blue flashes. In complete darkness, this appears especially vivid. The wake behind the stern turns into a glowing line, gradually disappearing into the black water. Some sailors admitted that in absolute darkness, even ordinary natural phenomena are perceived differently. The lack of external landmarks heightens attention to detail. There were also storms. The southern cyclones that pass through this region are no different from other storms in the Southern Ocean, but the lack of land around them makes their scale more tangible. Waves rise in long lines, the wind is steady and cold. In the darkness, flashes of lightning illuminate the water in brief frames, as if cut from a film. After the storm, a rare calm descends. The ocean continues to move, but the wind dies down. Space becomes smooth and empty once again. As the expedition leaves the Point Nemo area, the return to more vibrant waters becomes noticeable gradually. Voices begin to appear on the radio. A light can be seen on the horizon. The world once again fills with the presence of other people. And only then does it become clear that the center of the Southern Ocean truly remains one of the quietest places on the planet. Expeditions heading to the South Pacific rarely declared Point Nemo their destination. More often, it was a stopover, part of a larger route around the world. But it was at these coordinates that many captains first realized they were in a space sparsely populated. Modern navigation systems allow you to monitor ship movements around the world. In normal maritime areas, signals from other ships, commercial, fishing, and research always appear on the screen. In the middle of the Southern Ocean, the screen can remain blank for hours or even days. Not a single identifier, not a single marker. The radio airwaves in this region also change. Near the continents, shortwave radio waves are filled with chatter, port signals, and weather reports. Here, only occasional atmospheric noise is audible. Occasionally, distant transmissions arrive, distorted and weak, but more often, the airwaves remain almost empty. This isn't a technical anomaly. It's simply a lack of sources. Some circumnavigators who have crossed the southern latitudes alone have described a peculiar state that occurs after several days without encounters. At first, this seems normal. After all, the ocean is always vast. But then comes the realization that there isn't a single vessel within a radius of thousands of kilometers. The horizon becomes not just a line, but the boundary of the world. Southerly winds continue to move from west to east, forming a steady wave. Even in clear weather, the surface is rarely completely calm. Long ocean swells, generated thousands of kilometers away, pass through the Point Nemo area, preserving their energy. During a storm, the scale of space becomes even more apparent. In the absence of land, the waves don't break against the shore or lose their strength. They continue to move, creating a sense of endless energy. But the storm here isn't perceived as something unique. It's part of the general breath of the Southern Ocean. Research vessels passing through the gyre's center focused not only on water, but also on air. Carbon dioxide concentrations were measured, aerosols were analyzed, and ocean-atmosphere exchange processes were studied. The South Pacific Ocean plays a vital role in the global climate balance. Vast masses of water absorb carbon, slowly redistributing it across the planet. The region's remoteness makes it valuable for research. Local pollution sources have a lower influence here. The data is considered cleaner, reflecting the background state of the atmosphere. But there is another layer of observation: acoustic. Underwater, sound travels faster and farther than in air. Monitoring systems installed in the South Pacific Ocean are capable of detecting low-frequency signals traveling through thousands of kilometers of water. These signals could include ice cracking in Antarctic latitudes, underwater earthquakes, or the movement of large icebergs. Bloop was detected in the 1990s. It emanated from the South Pacific Ocean. Its nature initially raised questions, but was later linked to natural ice processes. Nevertheless, the incident served as a reminder that powerful natural events occur even in the most remote waters. At night, the Point Nemo area takes on a special atmosphere. Without light pollution, the sky becomes unusually clear. The southern hemisphere reveals itself in all its fullness. Constellations rarely visible in northern countries become clear and bright. When clouds obscure the stars, space becomes disorienting. Water and sky merge. The ship seems to be moving within a closed sphere. Even the wind direction becomes difficult to discern without visual cues. Some sailors admitted that at such moments, their attention to sounds intensifies. The splash of water against the side of the ship, the creaking of the masts, the noise of the wind. Everything seems louder. This isn't a mystical sensation, but a natural psychological response to the absence of external stimuli. Bioluminescence enhances this impression. As the hull cuts through the water, microorganisms react with brief flashes. In complete darkness, they appear brighter than in coastal areas. Glowing trails behind the stern remind us that life is present even in the ocean desert. Occasionally, expeditions recorded rare encounters with marine animals. Dolphins would accompany the vessel for several hours, then disappear. Occasionally, the silhouette of a whale would appear in the distance. But such encounters were less frequent than in more productive waters. It is this rarity that makes each observation significant. After a few weeks in the South Pacific, a person begins to perceive space differently, not as a route, but as a state. There are no familiar landmarks, no change in scenery. There is only water, sky, and movement. As the ship leaves the Point Nemo area and begins to approach more populated areas, changes become noticeable gradually. First, a faint signal appears on the radar. Then a voice is heard on the radio. A barely noticeable light appears on the horizon. The feeling of the presence of other people returns, and it is at this moment that it becomes clear how rare the state of complete remoteness was. Point Nemo harbors no anomalies. It doesn't attract legends of lost ships. Its mystery lies in its absence. This is a place where the ocean manifests itself in its purest form. Without shores, without cities, without a permanent human presence. And this is his quiet secret. There is a strange coincidence that makes Point Nemo even more unusual. The most remote place in the ocean has become the place where space returns. When a large spacecraft completes its mission, it can't simply remain in orbit forever. Over time, its orbit decays. Drag from the upper atmosphere slows the object, and it begins to gradually lose altitude. This process can take months or years, but the end is inevitable. Atmospheric re-entry. Engineers are calculating the descent trajectory so that the remains of the spacecraft will fall in a safe zone, and the safest zone on the planet turned out to be the South Pacific Ocean. The area around Point Nemo is remote from trade routes, islands, and continents. There is virtually no shipping here. The vast expanse of water minimizes risk. Orbital descent is a complex operation. The spacecraft receives a command to engage its braking engines. The orbit gradually decreases. At an altitude of about 100 kilometers, intense interaction with the atmosphere begins. The speed reaches several kilometers per second. The body heats up to thousands of degrees. Most of the structure burns up. But individual components, the engine blocks, fuel tanks, and strong fragments, may survive this stage. Their trajectory is calculated to fall precisely in the South Pacific. In 2001, the Mir orbital station ended its journey in just this way. Its deorbit was a symbolic moment. An era ended with its impact in the water at the most remote point in the ocean. Since then, dozens of cargo ships and satellites have ceased to exist in these waters. From the ocean surface, this process is almost imperceptible. At night, a bright fiery arc can be seen in the sky. A few seconds of light, then darkness. After a while, the fragments reach the water. The vast impact area stretches for tens or hundreds of kilometers. The debris goes into the depths. Beneath Point Nemo lies more than 4,000 meters of water. At this depth, the pressure exceeds 400 atmospheres. The temperature is about 2 degrees Celsius. Light does not penetrate. Metal fragments designed to withstand vacuum and cosmic radiation are immersed in cold, salty water. Gradually, they become covered with sediment. Marine microorganisms form a thin biological layer on the surface. Over time, these objects become part of the underwater landscape. This isn't a cemetery in the traditional sense. There's no single point where all the debris lies. It's a vast, scattering zone. But the very idea that the remains of space stations lie beneath the keel in the middle of the ocean gives the place an added dimension. If you draw a vertical line through Point Nemo, it will connect the depth of the ocean and the orbit. Below is a dark world of pressure and cold. Above is vacuum and radiation, and between them is a thin surface of water. The South Pacific Ocean is connected to space by more than just falling spacecraft. On a clear night, the movement of satellites is particularly clear here. The lack of light pollution makes them bright and visible. They pass silently across the sky, like slow-moving stars. At certain moments, the International Space Station is closer to you than any continent. This is not a poetic image, but the reality of distances. Meanwhile, the ocean's own life continues underwater. Hydrophones detect low-frequency signals, the cracking of Antarctic ice, underwater earthquakes, and the movement of icebergs. Water transmits sound over vast distances. In the late 1990s, one such signal, low frequency and powerful, attracted the attention of researchers. Its source was located in the South Pacific Ocean. It was later attributed to natural processes, but the fact itself underscored that even in the most remote waters, the planet remains active. The Southern Ocean is one of the least thoroughly explored regions of the Earth. Most depth data is obtained using satellite-based methods measuring gravity anomalies. Detailed ocean floor surveys have been limited. This doesn't mean there are secrets hidden there, but it does mean the space is vast. Point Nemo is the intersection of scales, the ocean that covers most of the planet, the space that surrounds it, and man in between. Here, the sense that technology is a temporary phenomenon is particularly clear. Orbital stations built over decades eventually return to the water. Metal and ceramics become part of the marine environment. Water accepts everything, and there is a quiet symmetry in this. When specialists calculate the re-entry of a large orbital object, they work with precision down to the second. The spacecraft travels at a speed of almost 8 kilometers per second. The slightest error in calculations can shift the impact zone by hundreds of kilometers. Therefore, the trajectory is planned in advance, taking into account the Earth's rotation, atmospheric density, re-entry angle, and possible fragmentation of the structure. At an altitude of about 120 kilometers, heating begins. The air here is thin, but at such speeds, even a thin layer of atmosphere creates colossal friction. The surface becomes hot, and the structure experiences overload. Most of the lighter elements disintegrate and burn up. The more massive fragments continue on a ballistic trajectory. The South Pacific region was chosen for a reason. It's vast. Even if fragments scatter for tens of kilometers, the likelihood of them hitting a ship or land is minimal. This isn't a single specific location, but a wide corridor stretching across the surface of the water. Sometimes the craft's descent is observed from ships relatively nearby. A bright line appears in the sky, breaking up into several luminous points. It looks like a meteor shower, but moving more slowly and steadily. After a few minutes, it disappears. Underwater, the process ends silently. The fragments, cooled by the atmosphere, enter the water, creating a brief surface disturbance that quickly fades into long ocean swells. They then begin to slowly descend into the depths. At the 4-kilometer mark, the pressure reaches over 400 atmospheres. The temperature is about 2 degrees Celsius. There is no light. Even if the fragment were brightly colored, its color would dissolve in the darkness. Over time, the metal begins to react with salt water. The corrosion process is slow but continuous. A hypothetical deep-sea expedition to the impact site would be faced with a formidable task. The scattering area could span hundreds of square kilometers. The seafloor here is covered with a thin layer of pelagic sediment, microscopic remains of organisms and mineral particles that settle from the water column. These sediments accumulate slowly, but over years they can obscure small objects. Deep-sea vehicles capable of reaching such depths exist, but even with them, finding specific fragments remains a difficult task. The area is too vast, and the accuracy of the impact coordinates is not always absolute. Thus, beneath Point Nemo lie components of space technology that once orbited the Earth but have now become part of the seabed. This is neither a museum nor a monument. It is the quiet return of technology to the natural environment. The vertical scale of this place is especially noticeable at night. Standing on the deck in clear weather, you can see several satellites crossing the sky. They move silently. Their light never flickers, and they leave no traces. It's a constant reminder of human presence in space. And at the same time, beneath our feet are kilometers of water, where the pressure and cold create conditions in which a person can exist only with the help of the most complex technology. The ocean and space have one thing in common. They both require protection. Without specialized equipment, humans cannot survive in either. And Point Nemo becomes the place where these two environments seemingly converge. The South Pacific Ocean is also interesting from a geophysical perspective. Tectonic boundaries lie beneath its surface, and active subduction zones are found in more southern latitudes. Underwater earthquakes generate low-frequency vibrations that propagate through the water column. Hydrophones detect these signals, even if the epicenter is thousands of kilometers away. The case of the signal known as bloop demonstrated how powerful natural acoustic events can be. Although its source turned out to be related to ice processes, the initial uncertainty sparked interest. The Southern Ocean is capable of generating sounds that can be heard across entire basins. The acoustic purity of the area reinforces this impression. Due to the lack of intense shipping, the background noise level is lower than in northern seas. This makes natural signals more noticeable to the instruments. Point Nemo is also linked to global climate processes. The Southern Ocean plays a key role in absorbing carbon dioxide. Vast masses of water exchange gases with the atmosphere, influencing the planet's balance. Research conducted in this region helps us understand how the climate is changing. Thus, Point Nemo is not only a symbol of isolation, but also an important element of the global system. It participates in the redistribution of heat, carbon, and energy. Yet her main image remains simple. Below is the depths, concealing traces of human technology and ancient marine life. Above is space, through which new vehicles navigate. Between them is a thin layer of water and air. This place reminds us that technology is temporary, while the planet is vast and resilient. Everything created by humans sooner or later returns to one of two environments, either water or the atmosphere. Point Nemo isn't the edge of the world. It's the center of a body of water where the planet's verticality is most clearly felt, and perhaps that is why it remains one of the most unusual places on Earth. When viewed from space, Earth doesn't appear to be a world of continents. It appears to be a world of water. The blue surface occupies most of the planet, and the continents appear as jagged islands scattered across the ocean. We live on these islands and are accustomed to thinking of them as the center of everything. But if you remove the names of countries, remove the borders and roads, it becomes clear the land is just fragments in the ocean space. And somewhere in the southern part of the Pacific Ocean, there is a point where the distance to any land is greatest. This is not the symbolic center of the world. It is the center of water. There's nothing unusual here during the day. The ocean surface can be calm or choppy, but it's no different from other parts of the Southern Ocean. The waves are steady. The sky is reflected in the water. The horizon remains perfectly level. But if you spend enough time here, another understanding comes. Space begins to feel different. In everyday life, distance is a number on a map. Here, distance becomes a real state. Within a radius of 2,500 kilometers, there is no land. There is no city to which one can mentally attach oneself. There is no shore to which one can move. There is only a circle of water. If the ship stops, there will be an infinite surface around it. If it moves forward, the landscape will remain unchanged. The clock will tick, the sun will rise and set, but the horizon will remain the same. It is a rare experience to be in space without external reference points. Over time, you begin to notice little things that once seemed insignificant. The shade of the water at midday, how it changes color before sunset, how the clouds stretch into long streaks in the wind. In southern latitudes, the wind can blow for weeks without encountering land. It drives long ocean swells that pass through the Point Nemo region without losing their shape. Even in clear weather, the surface is rarely completely still. The ocean is always moving. Beneath the keel lies 4 kilometers of water. At this depth, the pressure exceeds 400 atmospheres. The temperature is close to zero. Light does not penetrate. This is a world of slow-moving organisms adapted to darkness and pressure. And in these depths lie fragments of human technology, the remains of stations and ships that once orbited the Earth. Metal designed for a vacuum now rests in cold water. Above is the orbit. The satellites move along their trajectories. Sometimes on a clear night, they can be seen as small, glowing dots crossing the starry sky. Between space and the depths lies the thin surface of the ocean. Here, a person finds himself literally in the middle of two extreme environments. Point Nemo is a reminder of temporariness. Orbital stations are built for years, serve for decades, and then re-enter the atmosphere. The metal heats up, disintegrates, and falls into the water. Over time, it becomes part of the seafloor. The ocean accepts everything. But the ocean doesn't appear to be a conqueror or a keeper of secrets. It simply exists. Spending a night in this region, especially on a clear day, brings a different sense of scale. Without light pollution, the sky becomes unusually bright. The Milky Way appears as a dense, glowing band. The Magellanic Clouds appear as isolated islands of light. When clouds cover the sky, the darkness becomes dense. Water and air merge. The horizon disappears completely. The ship moves within a sphere of darkness. At such moments, it is especially acutely felt that there is not a single fire within a radius of thousands of kilometers. Not a single window. Not a single lighthouse. Not a single shore. And there is no tragedy in this. There is only a fact. We live in an era of constant connectivity. Satellites transmit signals. The internet connects continents. Maps show every point on the planet. But physical distance remains real. And in the center of the Southern Ocean, it feels especially clear. Point Nemo doesn't strive to be a symbol. It doesn't hold ancient legends. It's not the site of catastrophes or mysterious disappearances. Its peculiarity lies in its absence. Lack of land, lack of noise, lack of constant human presence. This is a place where you can feel the size of the planet without interpretation. As the ship leaves the area, the return to normalcy occurs gradually. First, a faint signal appears on the radar. Then, the voice of another captain is heard on the radio. A small light appears on the horizon. The world is becoming populated again. And only then do you understand that the center of the Southern Ocean is a rare state in which a person remains alone against the backdrop of a planetary scale. Point Nemo isn't scary. It's not overly inspiring. It doesn't demand attention. It's simply a reminder. It reminds us that the Earth is water, that most of its surface is not covered by cities, that distance is not just a number on a map, and that even in the 21st century there is a place where you can feel truly remote, in the center of the water. And there's nothing mystical in this silence. There's only scale. The ocean will continue to move. Currents will rotate. Satellites will pass over the surface. Metal on the seafloor will slowly be covered by sediment. And in the southern part of the Pacific Ocean, there will remain a point where land is as far away as possible. A point that is not visible to the eye, but changes the perception of space. The point where familiar geography ends and clean water begins